So I'm going to go ahead and get started. My name is Ann Scanello, and I'm a tutor with the Seeds of Literacy program. Today's lesson is going to be on linear algebra. And last week I taught a lesson on graphing, slope, and linear relationships. And this is kind of the second half of that lesson. So our learning objectives, first thing we wanted to do was get familiar with the linear algebra vocabulary. And we went through that pretty thoroughly last week. And then the second objective was to understand the parts of a linear equation. And we covered that last week and we practiced, but I want to review that again because there's a page that I think would make a really good note page. And then we're going to learn to identify the y-intercept, whether it be in a word problem, a graph, an equation, or on a table. And then we're going to talk about how to calculate slope. And that would be, you could calculate it from a word problem, a graph, an equation, or a table. So let's go straight to understanding the parts of a linear equation. So there's something called the slope-intercept form. Taylisha, are you familiar with this at all? It's y equals mx plus b.
Yeah.
Okay, good. So have you had, I know there have been several lessons through Seeds of Literacy on it. Have you sat through some lessons like this?
Yes.
You're awesome. That's good. Boy, you just stick with it. Okay, so
yeah.
The y equals mx plus b is what we call the slope-intercept form. But some people get confused. Oh, okay. The different parts of it, the y actually is the dependent variable. We talked about that a little bit last week. We'll talk about it some more in a little while. The m, this is the spot in the equation where you would find the slope. Sometimes the slope might be called the unit rate or just the rate for the problem. Sometimes when I was looking at GED practice problems, and there were some problems where they were actually referring to the constant of proportionality. All linear relationships are proportional. And so the constant of proportionality is going to be the same number as the slope or the unit rate. And then also sometimes you'll hear it referred to this position, this m or this slope, as the coefficient of x. And all that means is that it is the number that comes right along with the x, right in front of the x. The x in the equation is always going to represent the independent variable, and the b is always going to represent the y-intercept. Now, the y-intercept might be the beginning amount or the starting point if we're talking about a word problem. Also, it's going to be the value of y when x equals 0. So sometimes they will give you coordinate points, or they will give you a table. Say it again.
You said the y-intercept. The y-intercept is the value of y when x is 0.
That's exactly right. So when x equals 0, and so we'll practice some of those today. We'll be looking at a table. I think are the ones that I built. And in the table, you just find where x is 0, and right next to it, whatever that y is, that's going to be your y-intercept. Okay, so the slope, basic equation of a line, or the slope-intercept form, y equals mx plus b. It's actually always going to have the two variables. Y and x are going to remain in their normal places, but m is going to be replaced by a number. So when we have an actual equation, m will be a number, and that number will be our slope or our rate for the problem. And b, the letter b, is also going to be replaced by a number if we have a linear equation or a linear relationship. And that's going to be our y-intercept, or our starting point, or our beginning amount. So we'll always know that we've located our slope because it's going to be the number that goes right with the independent variable. And we'll always know that we found our y-intercept because it's always going to be just the number added on, not multiplied by a variable. So an example of a linear equation would be y equals 8x plus 5. So Taylisha, I'm going to ask you in this example that I've got here, what is the slope for this problem? For y equals 8x plus 5, what's the slope?
I have no idea.
Okay, because your brain is making it much harder than it needs to be. The
Okay.
slope is this letter m. So whatever
Okay.
number is right in front of x has to be our slope. So when y equals 8x plus 5, what's our slope going to be?
Our slope is 8.
That's perfect. So see if you can get this one. What is the y-intercept for y equals 8x plus 5?
5.
Perfect. That's it. It's that simple. Okay. So that's what we talked about last week. And I'm going to skip the vocabulary and all of that, and I'm going to go straight to our next objective. So we're going to practice identifying the y-intercept. And I think we did a few of these last week, and I think you might have actually joined us for some of this. Okay, so we're going to learn how to find the y-intercept, whether we're looking at a word problem, a graph, an equation, or a table. And you've already had a good start because you already found the y-intercept in an equation for me. Okay, now Taylisha, this page that I'm about to put up would be a really, really good note page. So if you have a way to, not right now, but after I finish out this page, take a picture of this page, or if you could jot it down in your notes, because when you go in to take the GED, they will give you some of the equations for linear algebra, but everything that I'm going to have on this note page is going to be stuff that you're going to have memorized. It's going to be things that you need to learn and memorize on your own before you walk in the door. So just saying. The first thing,
Okay.
if we've got a word problem and they're talking about the beginning amount of money, or we might be running a race and the starting point for the race. Sometimes we're talking about temperature and the starting point for the temperature. Anything that sounds like a beginning amount or a starting point, that's always going to be your y-intercept. So in a table, we talked about this one a little bit already, it's going to be the value of y when x equals 0. And we'll practice some of those.
Okay. Your
And
y-intercept is the value of y when x equals 0.
perfect. And on the graph, the y-intercept, that's where the line crosses the y-axis. So you know on a coordinate grid or on a graph, we've got the y-axis goes straight up and down, vertical, and the x-axis goes across, it's horizontal. So the y-axis, wherever the line, when they say graph, they really mean line because it's linear algebra, we're making lines. Wherever the line crosses the graph, that's going to be your y-intercept.
Right.
And then
Okay.
if you're given an equation, we've already practiced this one a little bit, the equation will always be in the slope intercept form, gotta stop saying that, and it will look like y equals mx plus b. Well, we know in the equation, there's going to be a number right there where the m is and a number right there where the b is. The number that is added on, or the number in this position that's not with the variable, that's always going to be our y-intercept. So those 4 things, if you can memorize that, and like I said, take a picture, write down notes, will be very helpful before you go in to take the test.
Okay.
So let's go ahead and practice. So at noon, the temperature is 30 degrees. For the next several hours, the temperature falls by an average of 3 degrees an hour. And then it says, write an equation for the temperature T and n hours after noon. We're not going to write the equation yet. We're not quite ready for that. But what would the y-intercept be? And the part of our note page that applies to word problems, I pasted it up here in the left corner. So it says word problem. We're looking, the y-intercept is going to be the beginning amount or the starting point. So at noon, the temperature is 30 degrees. For the next several hours, the temperature falls by an average of 3 degrees an hour. What would the y-intercept be, Tylisha?
Give me 1 second. I wanted to note something down.
Good girl.
Okay. At noon, the temperature is 30 degrees Fahrenheit. For the second hours, for the next several hours, the temperature falls by average of 3 degrees Fahrenheit an hour. What is the y-intercept? What would be the y-intercept? At noon, the temperature is 30 degrees Fahrenheit. I'm a guess. Is it
Okay,
30?
before you guess, don't forget that note page. I put a little part of it up here. So for the y-intercept,
Mm-hmm.
we're
It would
looking
be.
for the beginning amount or starting point. So what would the y-intercept be?
Oh, okay. So the y-intercept would be the 30 degrees Fahrenheit.
Perfect. That's it.
Okay.
See, and if you know that in your brain, if you know, oh, y-intercept, that's always going to be the starting point. You know,
Right.
it's really easy to get the y-intercept. That's why I say those notes can be really helpful.
Right. And mx plus b, it would be b is the y-intercept. So okay. Okay.
We're going to practice that too. You're doing great. Okay.
Thank
Damon never manages to make his allowance last for a whole week, so he borrows money from his sister. Suppose Damon borrows 50 cents every week. Write an equation for the amount of money that Damon owes his sister after n weeks. And we're not writing the equation yet. We'll do that in a little while. But right now, we
Okay.
just need the y-intercept. So he always runs out of money, never lasts the whole week. So when he runs out of money, he has to borrow money from his sister, and he borrows 50 cents every week. So we need the y-intercept. What's the beginning amount or the starting point for Damon?
50 cents.
No, that's not it. This is a
Okay.
tricky question, and this comes up a lot. So
Mm-hmm.
50 cents, that's how much he borrows this week, and he borrows it next week, and the next week, and the next week. That would be the rate for this problem, which is also the slope, but we're going to practice that later. So that's how much money he keeps borrowing every week. But that's not his beginning amount. So he got his allowance and he blew it. It's all gone. So now that the money's all gone, he has to start borrowing from his sister. So how much money does Damon have? What's his starting point or his beginning amount?
We don't know.
Yeah, we do. He got his allowance and he spent it all. So after he spent all of his money, how much money did he have?
None.
So what's our y-intercept?
0.
And it is pretty common for 0 to be a y-intercept. For a lot of problems, we're starting at the beginning. We're starting at 0. So that's a pretty normal situation, which is why I wanted to practice it.
Okay.
Okay, so now we're on a table. And this is one, I know you were writing down the notes on this one. We've got a table of values. And again, I put the little note page, my little clue up in the left corner. It says on
Okay.
a table, the y-intercept will be the value of y when x equals 0. So here's a table. So what's the y-intercept on this table?
Table value of y when x is 0.
Mhm.
Is 0?
That's it. People make this so hard. And honestly, if you didn't have that first Y-intercept note page memorized, it can be very confusing. But once you
Mhm.
know that, you just, let me see, X equals 0 right here, right next to it, Y is 0. Oh, it's 0. But
Mhm.
wait, there's more. And it does get a little trickier. Okay, so this is a
Okay.
different table. So now from this table, Taylisha, what's the Y-intercept on this table?
1.
No.
No.
Did you find on the table where X equals 0?
No.
It's not there. So
Right.
and this is the one, I think we were doing it last week, and I was saying, oh, I wish I had ooched it in. I used to tell my students, they didn't give you 0, so it's your job to figure out if X was 0, if we had a 0 right here, what would the Y value be? So let's use patterns. Let me see. We're going down 3, go down 1 to 2, go down 1 to 1, go down 1 more, we would be at 0. Now, if we're at 7, I have to go down 2 to get to 5, go down 2 to get to 3, go down 2 to get to 1. So if I need to go one more space over, I'm going to need to go down 2. So I'm at 1, and I need to subtract 2. Or I
Negative.
like to, what was it?
Would it be -1?
That's exactly what it would be. And that's a
Okay.
pretty common kind of problem too. They don't always, when they give you a table, they don't always give you X equals 0, and you have to figure it out. But that's a pretty normal difficulty level. This
Okay.
one is a little trickier. It's similar to the last one, but it's a little trickier. It's see if you can do it. Again, they didn't tell us when X equaled 0. They left off X equals 0 and 1. And so it's on you to figure it out.
Okay.
You want to try to figure it out, or you want me to help you?
I can try to figure it out.
You go for it.
Would it be -5?
You're awesome.
Cool.
You are doing fantastic. Nice. So you know that you needed to go down. Every time you go down 1, we
Mhm.
actually add 3 more. So we had to add 3 more and add another 3, which got us to -5. Good job.
That is a really good rule to remember because I would fail that every time.
I'm telling you, I had more students that struggled with linear algebra, and I would just say, copy down this note page. And in class, I would say, take out the note page because I want you practicing using the note page with that information on it. But you use it enough, you're going to get it memorized, and it makes all the difference. Okay, so this is on a graph. So now we've given you a graph, and I want you to tell me what the y-intercept is. And the note page is up here in the left corner again.
What is the y-intercept?
Yes.
3? 3? Okay.
Yep. Oh, I'm sorry. Wait, I just messed something up. Oh, I did. I took off my screen. That's what I did.
I was just gonna say, you didn't mess up. You just got to share your screen again.
Yes, I clicked. I thought I was clicking to go on, but I was hovering over unsharing or something weird like that. Okay. So the y-intercept is 3. Nice. Now, last week when we were going over our definitions, we talked about types of slope. We talked about positive slope, negative slope, and no slope or 0 slope. So are you familiar with those terms at all, Taylisha?
Mhm.
Okay. So this line, do you know, because we haven't talked about it this week, is this, what type of slope is it? Is it positive slope, negative slope, or 0 slope?
This is a positive slope.
No, it's not.
No? Okay. Is it a negative slope?
Yes, it is. And the way you tell, the same way that we read words and sentences, and we always go from left to right, that's the same way we read math, like math graphs. And so we start at the left, and as we move right, we're sloping down. So that's how we know it's a negative slope. So
Okay.
and I'll bet we have an example of a different type of a line.
Okay.
So this is a positive slope. Wait.
Okay.
Taylisha, what was your first answer that you gave me?
I think I said positive slope. I
And it
think
was
I said
negative was
positive
correct.
slope.
I just said it backwards just a second ago. So I wanted to make sure I didn't mess you up. Because
Okay.
as we're going from left to right, the line is sloping down. It's a negative slope. I'm thinking about
Okay.
the next example. Okay. So this
Now
one,
would this be a positive slope?
absolutely, because as we go from left to right, the same way we read a word or read a sentence, it is sloping upward. So it is a positive slope. And what is the y-intercept on this one?
1.
That is it. Nice job.
Thank you.
Okay, so now we're working with the equation. And I've got the note page up here in the left corner. In the equation, the letter B is going to represent, that's the spot where the y-intercept is. So this one is very basic, very straightforward. Y equals 2x plus 3. What's the y-intercept for this equation?
3.
Nice job. This one's a little trickier, but this is really common. You'll see a lot of equations that just look like that, and it will be up to you to figure out what the y-intercept is. Y equals 2x. What would the y-intercept be?
0.
Perfect. You are doing very well today. Okay, this one's trickier, or a little tricky. Y equals 5 minus 2x. What's the y-intercept this time?
5.
Perfect. Nice. I have a lot of students.
Like backwards, like, okay.
Big up here in the slope intercept form, we're adding two terms. And when we're adding, we're allowed to say mx plus b. That's going to be the exact same thing as b plus mx. And so sometimes when you see your equation, it won't be arranged in the order that you're expecting, but that's okay. You can see you still have a number multiplied by a variable, and then there's an extra number just kind of added in there, and that's the 5, and that's our y-intercept. Nice job. Okay, so how about this one? What would the y-intercept be this time?
Is it 5 or negative 5?
It's one of those two. You pick which one you think is it, and then give me your final answer.
Negative 5.
-5 is correct. Because
Okay.
to be in slope intercept form, you have to add on your extra number, and I thought I had it written a different way. And if you're good with your positive and negative numbers, subtracting 5 is the same thing as plus a -5. Good job. Now, how about this one? This one can be really tricky. Y equals 2. What's the y-intercept this time?
There isn't one. The 0 again.
Well, we're missing something. Okay, so let's look up here. This is our slope intercept form of the equation. So we have our y equals. So they gave us the y equals like they're supposed to. But we're expecting to see an mx, and we're expecting to see a b. Which one of those terms did they leave off? The the number multiplied by x, or did they leave off the number by itself?
The number by itself.
I've got 2 all by itself right here.
Oh, so okay, they left the slope off.
Nice. Okay. So this is what's missing. So, and we'll talk about that in just a second. So this is what's left. So what's our y-intercept?
2.
That's it. Okay. So now they left off the slope. Huh. What that means is that the slope for this problem would be 0, because 0 times by any variable is still going to be 0. And so we don't write it that way. We wouldn't write 0x plus 2. So they just skip that part altogether. So this is okay, we didn't talk about it, but I want to see if you can figure it out. So we've talked about lines with positive slope. From left to right, they go up. We've talked about lines with negative slope. From left to right, they go down. How about this? The slope we just said for this line is 0. If the slope is 0, can you show me with your arm, what is that line going to look like?
It's gonna be like this. It's gonna be straight.
You're awesome. You are awesome because you didn't have, I don't think you were here for the vocabulary last week. That's exactly what it's going to be. That's going to be 0 slope. You'll also hear it called no slope. Perfect.
Thanks.
And, oh, so the y-intercept would be 2. You already got that one. Okay. So now we're going to talk about slope. And slope, whether it's a word problem, a graph, an equation, or a table. And this is another one of those note pages. So if you've got, like I said, when I get it all put up there, you can take a picture of it, or this would be something to write down for notes and to hang on to this while you're practicing, okay? So if it's a word problem, the slope is going to be whatever number is the rate, or sometimes they'll even call it the unit rate. Like a minute ago, we had our poor child was borrowing money from his sister. The amount that he borrowed every week, that's the rate. If you're talking about speed, you'll get a lot of problems talking about, how fast you're going and how far you go in a certain amount of time. Your speed is your rate.
Okay.
If we've got a table, the way you find the slope, because you'll be asked to do that, you take the change in your y values and divide it by your change in your x values. And we're going to practice that in a minute.
Okay.
And then on a graph, have you ever heard slope equals rise over run?
Yeah. But I could never get that. I could never understand that.
And honestly, when I was in school, it was confusing. I remember thinking that doesn't make any sense, or that it just seemed very overwhelming. When I started teaching it, I realized that is so much easier than my teachers made it seem. So we're going to talk about how to do rise over run for a graph. We'll practice that. And then the last one is in an equation, and you've already done this one for me. In an equation in the slope intercept form, which is y equals mx plus b, this location for the m, whatever's in that spot, is our slope. So be careful, because we've seen sometimes the y-intercept comes first and the slope comes second. So whichever number is being multiplied by the x value over and over and over, that's going to be your slope. The number hanging out there all by itself, that's always going to be y-intercept. Okay, so that's the note page, and I'll have it up in the corner, so if you need to continue writing it. Okay, so let's practice some of our problems again, and now I think we know enough to write the equation. So it says at noon, the temperature is 30 degrees. For the next several hours, the temperature falls by an average of 3 degrees an hour. What's the slope? And remember, the slope is the same as the rate or the unit rate. I've got it in the little cheat sheet up in the left corner.
Okay. What is the slope?
Yes.
For the next several hours, the temperature falls by an average of 3 degrees Fahrenheit. The slope is 3 degrees Fahrenheit
You're
an
close,
hour.
but
Is
not
it
quite.
3?
Read it again, starting at the word for the next. So start right there and read the rest of that sentence.
For the next several hours, the temperature falls by an average of 3 degrees an hour. So, is it for the next several hours?
Nope. You said 3, and that's
Mm-hmm.
close. But if it
Oh,
changes by 3 degrees an hour, that means it keeps getting bigger and bigger and bigger. Is that what's happening here?
it says it's the temperature falls, so it's go down. So the temperature goes down 3 degrees an hour. What would the slope be? The slope would be for the next several hours, the temperature falls by average of 3 degrees an hour. The slope would be 3 degrees. 3. I don't know.
Well, okay, it starts off at 30 degrees. If the
Okay.
slope is 3 degrees, then after an hour, the temperature will be 33 degrees, right? But the problem says the temperature isn't going up. The temperature is falling. So we need a number that means it's falling 3 degrees. What's a number that means it's going down 3 degrees?
A number that means it's going down 3 degrees.
Yes.
A number that means it's
You
going
keep
down.
telling me +3, and it's not +3.
Oh, so it's -3 because it's going down.
Yes. Yes. Now be careful. That's what makes word problems tricky, is that,
Okay.
you have to understand. That's why I love to draw pictures. This one was tricky to draw a picture, but you have to understand, oh, wait, that temperature is actually going down, not going up. So it's a -3. Okay.
Okay.
So now we need to write the equation. And did I put I did. I put the other little cheat sheet up here. To write an equation, we know that the slope will be the m spot in y equals mx plus b. So see if you can write this equation for me.
No. Would it be y equal -3x plus 30?
You're awesome.
Cool.
Don't you feel smart? It's like when you can do something like that, when you can take this word problem and then just whip out that equation, it just makes you feel confident.
Mm-hmm.
Nice
And
job.
word problems was something that word problems are really heavy. It's like 5 word problem questions on the GED.
And they do that, at least 5. And they do that because they want to make sure that you're really understanding because that's the way the real world goes. You got to go out in a real job, you've got to understand the situation and be able to turn it into math. Okay, so I wrote the equation a different way, only because yours was absolutely correct. In this equation, they suggested that we used a capital T for temperature and a lowercase n for the hours afternoon.
Okay.
So, and we're allowed to do that. They do this so that this equation, it's a lot easier for someone to look at it and see, oh, wait, if n is the hours, I can see that it's going down 3 every hour. And it started at 30, and that equation is going to give me my final temperature. So In the slope-intercept form, they always use the variables y and x to represent the dependent and independent variable. But very common in algebra, they'll substitute other letters of the alphabet that help us understand what the variables are that we're actually talking about. So I just wanted to show that one. Okay, here we're back to Damon again. Never manages to make his allowance last for a whole week, so he has to borrow from his sister. He borrows 50 cents every week. What's the slope, or what's the rate?
50 cents.
Nice. And I love that you said 50 cents, because I get a lot of people that say 50, but you have to be careful. Oh, wait, that's cents. So it's like writing 0.50. So it will make a difference. Now, so write the equation. We found the y-intercept before, and now we just found the slope. So what's the equation for this word problem?
Um, 50 y equals 50x plus 0.
I think in your brain, I think that you've got it correct. I'm just curious how you would write that down. Do you have a piece of paper there?
Yeah.
Write down that equation and hold it up to the camera, because I think that you know it. Just the way you said it made me nervous.
I don't think you can really see it.
Hold
Let
up.
me write it.
You're really, I was close to being able to see it.
Okay, I'm going to write it bigger.
Okay. Okay, oh, I see it at the bottom. Hold up now. Okay, now hold it still. Lift it up a little bit higher. And that just looks like 50x, doesn't it?
Yeah.
It's 50 cents. Remember what I told you?
Oh, so it has to be a decimal.
Yes.
Oh,
so
really? Okay.
Because you had told me 50 cents before, and we talked about the decimal. That's a very common mistake. That's why I wanted to, was use something less than $1.
Okay, so y equals 50 cents. X plus 0.
Nice job. Or 0.50x is fine. You could have said it that way. Your
Okay.
original equation, when you wrote 50x plus 0, that also would work. But when you're all done, you're going to come up with the number of pennies that he has. And that's just weird.
Okay.
We're talking about money. We don't state things in terms of pennies. We state things in terms of dollars. So make sure when it's 50 cents that we write 50 cents. And then again, they told us to use M for the total amount of money, and and N for the number of weeks. And so M equals 0.50N. And also, you put on the plus 0. That is fine. That is absolutely a correct answer. So the answer I have written here in red is correct. It just looks odd. People don't normally write plus 0 because it just goes away to nothing. So what you'll see is M equals 0.50N.
Okay.
Let's try another one. Okay, so now we're on a table. And so we need to practice. We really haven't talked too much about this one. So on a table, we need to look at our Y values, and we need to see how those values are changing. And then we need to look at our X values, and we need to see how those values are changing. So I always used to tell my students, before you try to write an equation from a table, I want you to analyze the table. And when I say analyze the table, this is what I mean. You put these little carrots, and it just shows, it kind of directs your brain to thinking from 0 to 4, what happens? So from 0 to 4, it went up by 4. Check the whole table, because sometimes someone will throw in a non-linear relationship, and that might be something you have to identify. But from 4 to 8, it went up another 4. From 8 to 12, it went up another 4. 12 to 16 went up another 4. So here in our little formula, change in y, every time it's going up by 4. So that would be a 4. Now we need to look at our change in x. And so most tables, I'm not going to say most, I'm going to say many tables go up by 1, which is really convenient for us. But not all tables. We're going to have some different examples. So now, if on the y side, it goes up by 4 each time, and on the x side, it goes up by 1, our slope would be positive 4 over positive 1, which we're just going to write as 4. I mean, 4 over 1 is the same thing as saying 4. So that's our slope. Why don't you see if you can write an equation for this table?
Okay. Y equals 4x plus 1.
You're really close. You've got most of it correct. Y equals 4x is correct. Now look down at your notes or think back to what we were doing before. This is the table. How do we find the y-intercept on a table?
Is it wherever the line crosses?
Nope, that's on a graph. Okay,
Oh,
so
okay.
on a table, we look and we find where the x equals 0. Whatever the y is, that's going to be your y-intercept.
Right. Okay. So it'll just be y equal 4x.
That's it, yeah. Because plus 0, we don't want
Yeah.
plus 0. Y equals
Right.
4x is correct. Nice.
Okay.
Okay.
I can remember both. I can remember the table and
Oh,
the
there's a
graph.
lot of stuff, girl. Writing them down is a good idea.
Yeah.
Maybe at the end, I'll go back to those note pages, and your phone will take a picture, right?
Yeah.
Okay. At the end, maybe I'll go back and you can take a picture of those. Okay. So let's try
Okay.
this one. So now we
Okay.
need to find the slope from this table. And I'm going to tell you, this was the hardest, weirdest table I could possibly find. Because my thought was,
Yeah.
if you could do this one, most of your problems working from a table are going to be pretty easy. But that's okay. You can do it. I have total faith in you. So our notes are right up here. So in the table, we're going to take the change in y divided by the change in x. And I always tell my students to analyze the table, and that means we're going to put those little carets. So Taylisha, I want you to look at the y side. Every time, what is happening?
It is 2 to negative 2. It is that's okay, so 2 to negative 2, that's minus. Negative 2 to negative 6 is minus 4. And then negative 6 to negative 10 is minus 4.
And
So
what
it's
was positive 2 to negative 2? What was that?
that was minus 2.
Nope.
4.
Yeah,
Oh,
but
so it's negative 4.
negative
Okay,
4. So our
okay,
change in y is negative 4. So you can write that down.
change in y is negative 4.
And a lot of times, like I said, our x side, they'll count by ones for us. They'll count by tens. They'll do things that are really easy and convenient. This was the ugliest table, one of the ugliest I've ever seen. First of
Yeah.
all, our numbers are getting smaller, which is very strange. And they certainly aren't counting by 1 or 10 or 100 or anything like that. So see if you can figure out, what are they doing? How is our x changing each time?
The x is changing by -6.
It is. So what's our slope going to be?
The slope is going to be -6.
Nope. Remember, we
Nope.
have to
The
turn
slope
those
is
up
going to
here.
be, you have to divide.
The change in y. So what did you just tell me the change in y was?
So
Oh, you know,
-4.
you said it. I think I've got it up here. Yeah, I'll put it up there so you can see it. Okay. So
-4 divided by -6.
perfect. So rewrite that. That's a correct answer, but that can be simplified. What would that be simplified?
-4 divided by -6. That would be -4. Okay, -4.
Okay, let's take it one step at a time. We have a negative number divided by another negative number. Do you remember what kind of an answer we're going to have?
It would be a positive.
Yes, it will be. So it's going to be a positive slope. Okay. So we've taken care of the negatives. Now all we have to deal with is 4/6. Can you simplify that fraction? You can leave it in fraction form. Don't worry about going to decimals. It's
Yeah,
actually better to work with fractions. So what is 4/6 when you simplify it?
4/6 is 1 and 2/6.
Nope. We've got the 4/6. I wish, oh, I can do it this way. Wait a second. Let me grab a marker.
Okay. Oh,
Okay.
it's
So
0.6.
we have 4/6, and I can divide both of those by 2.
Oh, 2/3.
That's it. Nice. Yep. So our slope is going to be -4/6, which is the same thing as 2/3. Good job.
Okay.
We have to write our equation, and this equation is ugly. You try to do it, but it's okay to give up because it's kind of hard. But go ahead, you start the equation for me.
Okay. Y equals 2/3x plus -4. Is that right? -4.
No.
Y equals, no.
No, I was
Okay.
thinking you actually, I was trying to understand what you were saying, but you've got every part that I thought you should be able to get, you've got correct. Okay, so you've got, oh, hold up, I need to go backwards. No answers. Okay. In order, so the y equals 2/3 x, you had that part perfect. In order to get the y-intercept, we have to go back to the table and we have to find where x equals 0. Well, they didn't give us where x equals 0. So like I always say, we have to ooch it in. It belongs right here between the 3 and the -3. So over here, I created a bigger table so you could see what we're talking about. So I have the 3, just like they did, 3, -2, and I have the -3, -6. But there were all these values in between that I filled in to help us get our y-intercept. So the 0 would be exactly halfway between the 3 and the -3. So I would say to myself, oh, well, so then my y-intercept would be exactly halfway between -2 and -6. And you said -4. Why did you say -4? Did you say it because it was where
The
did you
rate,
get 4 from?
I said it because it was the rate of change and the y-intercept.
It's the y-intercept, but not because the y values went down by 4. It's the
Mhm.
y-intercept because if we were to ooch in x equals 0, our
Mhm.
y value here would have been -4. I
Okay.
wanted to be able to show an example of how to use this system to find a y-intercept, because on all tables, they don't always give you x equals 0. I will say anything that you see on the GED, I would not expect to be this difficult. All the other examples in this lesson today, yeah, they're fair game. This was, I thought, very tricky. So the equation y equals 2/3 x plus a -4, but more typically you'll see that written as y equals 2/3 x minus 4. But because plus a -4 is the same thing as subtracting 4. Okay. How about this one? See if you can calculate the slope from this table.
Okay.
So we have to find the change in y and then divide that by the change in x.
Okay. Okay, so the change in y is +3 + 3 + 6 + 3.
Good girl. You went all the way through. Awesome. Okay. Now go ahead and look at your change in x. You have everything perfect so far.
And then 1. Okay. So the change in x is +3 + 3.
That's in y.
That's in y. The change in y is +3 + 3, but then it's +6. Then it's +3 again.
Okay, so what I did here with the red arrows is what you just told me. In these 3 spots, it went up 3.
Mhm.
Then it did something different here between 7 and 13. So what happens on
Mhm.
x? What happens? How much is x going up by each time?
X is going up by 1, and then when it gets to 2, it's going up by 1, but when it gets to 2, it goes up by 2.
Nice job. Okay. So it was going up by 3 in most places, and it was going up by 1 in most places. So what would the slope be for the top part of this table?
Um,
The change in y was how much?
the change in y was 3.
Nice.
So
What was the change in
3
x?
3 divided by 1, it would be
That's it.
3.
Perfect. Okay, but we have this weird spot in the table where things changed. So let's look at that. How much does it go up from 7 to 13? How much does it go up there?
For the y, it went up 6.
And
And
how
then
about for the x? How much did it go up?
it went up 2.
Nice job. So what's the slope for that one little section of the table?
3.
Perfect. So you know what? The slope at the top of the table and the slope in that middle section, it was all 3. The only thing they
Okay.
did, and you'll see this every once in a while, they were being nice to us. Our x was going up by 1, but they skipped a number. And so you'll see that. I just wanted you to be familiar with it. So when you've got a weird spot in your table, test it. The top of the table, the change in y was 3 divided by the change in x of 1. So the top of the table, slope is 3. The strange part, it was change in y was 6 divided by change in of x is 2. Slope is still 3. So what's our slope for this whole table, Taylisha?
3.
It is 3. So what's our equation?
The equation is y equals 3x plus
I've got my fingers crossed because you can do this.
um okay, 3 0.
How do we find the y-intercept from a table?
We have to, x is already at 0.
So what's the y-intercept?
So the y-intercept is
X is at 0. So we look
0.
over here at y. What's the y-intercept have to be?
The y has to be 0, 1, -2.
Nope.
No, 1.
You need that. It is 1. You need that note page. Okay. When x is
Okay.
0, whatever the value right next to 0 is, that's going to be your y-intercept. So if y-intercept is 1, tell me my equation again.
Y equal 3x plus 1.
That's it. Good job. Okay. So now I'm going to get through explaining rise over run, but we probably won't get to all these practice problems. But that's okay,
Okay.
because next week I'm going to do linear algebra continued, because I have a whole, in addition to finding more slopes, I've got a whole little basic mastery section that we can go through next week. Okay, so finding or plotting slope on a graph. And a really common formula that you hear about is rise over run. Up here on my little note page section, you can see that I spelled it a really strange way. I spelled rise as R-Y-S-E, and I spelled run as R-X-N. And I did that because a student a long time ago told me, Miss Scanello, I spelled rise and run this way to remind me that the rise means I'm looking at my y-axis, looking up and down, and the run reminds me that I'm looking side to side. I'm looking at my x-axis. So in order to find the slope, we just look at how much the line goes up and down and divide by how much it goes across. But let's look at an example of that. So this is a line, and they're telling us that our slope is 2/3. Oops, I didn't mean to do that. They're telling us that our slope is 2/3. So here's our line in yellow here. And so you can see they took a point on the line. And in order to get to a second point on the line, we're only allowed to travel on the grid line. So we can't travel on the yellow line. We have to travel on those really faint gray lines. So we have to go up 2 boxes because the rise was 2, and we have to run 3 boxes. So go up 2 over 3. Put a point. That point's on our line. Rise 2, run 3. Put a point. That point is on our line. Okay. Bob slope. Bob walks 3 blocks in 1 minute. So this line represents Bob's slope, or his rate, his walking rate. Okay. So you can see the line, the green line here, the heavy green line. It goes through the origin, so that's the point 0, 0. And starting there, because he's starting at the beginning point, he's starting at 0. We rise 3 boxes, and we run 1, and we put another dot, and we've got the second point on our line. We could go up 3, 1, 2, 3, and over 1 box. And this point right here would also be on Bob's graph. Okay, so now Jane, she walks a little faster. She walks 5 blocks in 1 minute. So for her graph, we rise. We can only travel on the grid lines, only go straight up and down or straight across. We're going to rise 5 boxes, 1, 2, 3, 4, 5, and we're going to run 1 box for a second point on her line. Okay. Now, I've got the two graphs being compared. Jane's graph is more steep than Bob's. So even if we didn't know that she walks 5 blocks per minute and Bob walks 3 blocks per minute, because her line is steeper, that tells us that she's faster, or that her slope or her rate is going to be a bigger number. So I decided to add another friend on here. So we're going to look at Joe. Joe is a very slow walker. He only walks 1 block in 1 minute. So look over here on Bob's graph. Let me see if I can get my pointer going. Look over here on Bob's graph. So in order to plot Joe's line, we're going to start at the origin. We're going to go up 1 box, over 1 box. We could put a dot there. Up 1 box, over 1 box, put a dot. And when we graph Joe's, up 1, over 1, up 1, over 1. Same thing, I put Joe on Jane's graph too. Rise is 1, run is 1. Rise is 1, run is 1. And so you could see, even if you didn't know the numbers, you could look at either one of these graphs and you would know, well, Joe is a slower walker than Jane. He's also a slower walker than Bob. Okay, and our time is pretty much up. But I just want to do, oh, that's weird. Okay, I just want to see if you could calculate the slope on this graph. So Tylisha, can you see, do you have a different page or are you still looking at Bob's slope?
No, I have a different page.
Okay, so but sometimes my thing screws up. It's showing me Bob's over there, but okay. So on this line, we have to find 2 points that exactly go through the grid lines. So the origin, it goes straight through the grid line there, but I put red dots in all of the places where the line crosses through a spot where the gray grid lines are crossing. So if I've marked those spots, I want to see if you can figure out what the slope of this line would be.
Okay.
So again, we always start at the left, and I have 3 dots. You only have to pick 2, so you can pick any 2. Start at the left. We're traveling from 1 dot to the next dot, and you have to say, okay, how much do I need to rise? Now, how much do I need to run? Go ahead and tell me.
Okay. Rise is 1. 1 over 5. The run is 1.
Nice.
And the rise is 5.
Count that one again. You want to know what you're doing? You're counting intersections. I always say like bunny hops. So this counts as 1, 2, 3. So we're actually counting boxes, not the little intersections.
Okay. 4. The
Yes.
rise is 4.
Okay. And the run was 1. So what's the slope?
4.
Nice. What's the y-intercept?
0.
Perfect.
Well, 0.
So what's the equation?
Y equal 4x.
Don't you feel smart?
Thank
Get caught
you.
up with you here.
Thanks.
Nice job. Okay. That was a really, that was better than a start. Next week, I'm excited. If you can log in again, we've got a few more practices like this, one other new type of problem, and then I have this whole sort of mastery page.